Alrighty, so we're down to the last video. So ATP is what we need to make. That's our energy molecule. How do we get there? Well, we can get there from taking carbohydrates, protein, and fat, and disassembling them using oxygen and making CO2 and water and making a ton of ATP. That's aerobic metabolism. Folks, when you're at rest or mildly active, that's what your body would prefer to do. Well, Professor, why would it prefer to do that? Because even lean people have plenty of body fat. And fat is 9 calories per gram. It makes way more ATP molecules per molecule of fat than you would with protein and carbohydrate. So we love making ATP with oxygen. And that's the body. So at rest, watching TV, sleeping, that is the preferred fuel source. Fat plus oxygen goes to CO2 and water, and you make a ton of ATP. And it's actually made in a part of muscle cells called mitochondria. Mitochondria are kind of like little engines, and fat and glucose go in there, and oxygen goes in there, CO2 and H2O come out, and you make a ton of ATP. So that's when you have plenty of oxygen available, right? So oxygen comes in to the mitochondria. Let's say this is your muscle cell, and we get plenty of fat. We get glucose. Some of this fat is from body fat. Some of this fat, by the way, is in the muscle cells. Some of this glucose is from the liver. Some of this glucose is from glucose stored in the muscle cell. We're sending it into the mitochondria. Out comes CO2, water, and we make a lot of ATP. This is aerobic. Hiking, jogging, running, cycling. Anything you can do long distance and long time, it's got to be aerobic. It has to be. Otherwise, you couldn't do it very long. But what about athletes like boxers, wrestlers? Their issue is an oxygen issue. They're trying to exercise in a manner where they just can never breathe well enough, or their heart can't pump enough oxygen to your muscle tissues. If you can't get oxygen to your legs because you're cycling really hard, you can't use mitochondria. And if you can't use mitochondria, you can't disassemble molecules into CO2 and H2O and make a lot of ATP. You can't use fat. Frankly, you can't use glucose. Then how does somebody run a 400-meter, Professor? We don't burn anything when we're doing that. We're converters. Anaerobic people without, I didn't say no oxygen, because you're not passing out when you're running around a 400-meter race, right? You're getting enough oxygen, but not enough for your legs. You're anaerobic. So instead of burning glucose, we convert it. And what do we convert it to? Lactic acid. I know many of you have heard of lactic acid. So we make ATP and we make lactic acid. By the way, muscles don't like lactic acid. They're going to pump it out into the bloodstream. They don't want it. The problem with lactic acid is, and not only lactic acid, but other molecules, when they build up in the muscle tissues, within 30 seconds to 45 seconds, they cause fatigue. Then they cause pain. Your legs are screaming at you when you're running. And frankly, they cause muscle failure. You will cramp up and stop running. So for the anaerobic type of sports, they last about, let's say, 30 seconds to a minute and a half. And then eventually you're spent and you got to rest. It's the classic high school gym sprint a lap, building up, doing a lot of converting, and then walking a lap of your high school track, doing a lot of burning, converting and burning. Aerobic people burn, anaerobic people convert. And the only issue is that lactic acid. Once it builds up in the muscle tissue, you don't want it there. You actually want to pump it out. And that's what muscles does. It takes the lactic acid, puts it into the blood. Let's say you're walking your lap in your high school gym class after you sprinted a lap in your high school gym class. You're taking the lactic acid that builds up when you convert. You put it into the blood. It travels to the liver and gets converted back to glucose, which goes back into the blood and goes back to your muscle tissues. This is called the Cori cycle. Swimmers do a lot of anaerobic stuff, right? You're swimming underwater, you're turning at the wall. When a swim athlete leaves the pool, he or she is loaded in lactic acid. And they probably didn't burn that much fat in the pool. They did a lot of conversion in the pool. Swim, swim, swim. Get to the end of the lane. trying to get oxygen back into your body, right? So you really don't burn the fat in the pool for swimmers. They burn the fat when they get out of the pool. They use fat in the liver. Yes, they break it down to get the energy to convert lactic acid back to glucose. Swimmers burn their fat out of the pool because it's such an anaerobic sport. And that's why when you see swimmers get out of the pool, their whole body is just spent, right? Because there's lactic acid everywhere. Runners build it up in their legs. Swimmers build it up everywhere. They're spent. There's lactic acid everywhere, and it's fatigued the body. And they need to go through the core recycle process. Yes, running after you sprint, doing a good walk or a cool down helps the lactic acid recovery process. Okay, so all those work great for when you're burning, converting, and if you can't do either of those, you're doing the creatine process, where you're rapidly breaking down creatine because you want to throw a ball really far, really fast, and you're going to remake ATP. The phosphogene system works for about 10 seconds. It has nothing to do with macronutrients. It has nothing to do with carbohydrates, protein, and fat. It's only concerned with regenerating ATP in the muscle tissue. The type of folks who use creatine are power athletes. And yes, taking creatine as a supplement will build up muscle creatine. Can you lift more weights? Well, no, but you can lift the weights you're lifting longer. Creatine is considered an ergonomic advantage supplement. Pro athletes and collegiate athletes do use creatine to build up their muscles' creatine levels. And here's a good example of who's burning what, right? Aerobic people who are walking are burning fat and a little carbohydrate, burning, disassembling in the mitochondria with oxygen into CO2 and water. When you lift weights, you're using creatine, but you're still pretty aerobic, aren't you? No one's panting in the gym. Here we have an athlete that's burning a little less fat, using a little more carbohydrate. She's probably doing a little bit of converting. Because, there are times in running when you're sucking for oxygen. Cyclists, breathing a little harder. Basketball players, sprinting up and down the court. Burning, but a little more converting. Remember, we don't convert fat. We only convert glucose. And then your 200-meter athlete, it's aerobic a little bit because they're going 200 meters, but it's also very anaerobic. A hurdler is a big converter. And so is she really burning carbohydrate? No, she's converting it. But look what she's using up a lot of, carbohydrates. So track athletes are carbohydrate burners, users. Either they're converting the carbohydrate or they're burning the carbohydrate. Oh, I guess that's it. So these are long videos with a lot of information. I didn't go into great detail, but I tried to cover it in a way that explains the burn versus convert versus regenerate, which is the ATP and the creatine. And hopefully, if you need more details, it's in the notes, but if I haven't covered everything, we can Zoom, we can do an in-person office hour, or we can chat back and forth via email. Okay, that's video number 5.